Right. Can you all see? Can you all see my screen? Everybody? Good. Let's do as many questions as we can. You all get better with questions. So remember, maths is our subject, okay? Maths is our subject. So please don't let me down when it comes to maths. I want to give you the rules. Here are the things. Okay, we're going to make it very simple. Then we do many, many questions. It's all about questions. You'll get better the more questions that I'll be doing. So the more the questions. So anyway, here it is. It says probability. This is probability. The first one is probability of an event is equal to the number of successful trials over the total number of trials. This is the first formula for probability. Okay, probability of an event is this is the first formula which I want you to use. The number of successful trials over the total number of trials. Then the second thing we're going to use, I always tell you, is that when you have one probability or some other probabilities, I'll make it make sense. So don't worry about it. We're going to make it make sense in questions. What I'm giving you here is the four methods, okay, the three methods rather. We could say the three methods, the three things that you have to know when you're doing probability, and you're just going to use one of them, but you're going to be combining, okay? So you need to be able to put it in a question. So probability, okay, what you must know is that the sum of probabilities is 1. When you add all the probabilities, you must get 1. Then the third thing that you're supposed to know is that when you use the word and, you should multiply. And when you use the word or, you should add the probabilities. When you use the word and, you are going to multiply. When you use the word or, you add. Yes. Probabilities is 1. When you are given probabilities, if they ever do that mistake, listen, if Cambridge or whoever ever does the mistake of giving us probabilities, okay, in a probability question, they must not give us probabilities. If they give us probabilities, we know how to get it. We know that probabilities add to give you 1. So we'll just subtract the probabilities they have given us from 1. Let's go to such questions, okay? I'm going to start with the questions that need us to use this so that people get it. This method, eh? Wait, let me take. Yes, hi, Wendy. No, I'm now unmuted. Okay. Can you hear me? Am I muted? Can you hear me? Okay, good. Wendy, can you hear me right now? Okay, good. So, probabilities add to give you 1. Don't forget, people, probabilities should add to give you 1. So if you know this, you know the whole chapter. The hard thing, oh, Wendy can't hear me. Ooh. Wendy, check the YouTube link, okay? Go to my account on YouTube and check I'm live. Search Clarify Tutorials, you'll be able to see. All right, so Mr. Clarify, what are you saying I should know before we go into questions? You should know that I am not going to do any solution that is not going to use one of these three. Either I'm going to find probability by saying, I'm going to take, let's say they ask me, what is the probability that you are going to get green? I'll look for the number of green things, okay? I'll look for the number of green things, then I'll divide by the total number of colors, the total number of things that are there. That is the probability where I can use. If I have numbers of things, I'll use that one. If I want to get probability and they've given me other probabilities,
I'll just say 1 minus the other ones, then I'll get the one I want. Because probabilities add to give me 1. Listen closely. The only time we are subtracting is in the second one. That's the only time we are using probabilities to get a probability. It's very different from the first. From the first one, we are using number of things. In the second one, we are not even looking at how many there are. We are just saying 1 minus other probabilities will get the one we want. And then here it is now when you see them use the word and or the word or. Remember, if you see a question which says find the probability that both, it's just the same as and. Okay, you change it to and. Both is and you're going to multiply or you're going to add. Let's go to write it down. It will make more sense with questions. Let's do this question. Blah, 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 blah. I'm going to read the question itself, okay? This is a lot. I can read this, but I won't read it first. Okay? If I read it, look at the lines that I'm going to read here. She can win, lose, or draw. So I know that there are 3 options, which means I'll need probability of all 3. Okay? If I add probability of win plus probability of lose plus probability of draw, they'll give me 1, because all probabilities add to give you 1. We know that. Probabilities add to give you 1. We know that. It's the second thing we said here. All right. Anyway, let's see. We're looking for any hint. Any hint, we'll take it, okay? Probability that she wins the game is this. So we're going to write probability of win is equal to 0.28. But we don't know the probability of lose, and we don't know the probability of draw, because they told us she can win, lose, or draw. So we don't know these other ones. Okay, now let's go read the question. Jacinda is twice as likely to draw the game as to lose the game. Oh, she is twice as likely. Twice as likely. So whatever you are, she's twice as likely to draw. So there's 2 times the chance that she will draw, and in here it will be just X. So whatever you put for lose, she is 2 times as much to do it when she draws. So basically, let me teach you what trick is working here. We are not even yet using this. What is working here, or what will help you to do this when you are now doing your own question? What is, because look, IG is not going to change. I'm not the one who sets it. If you're not happy with this question, we have to just keep doing it until you get it. Because that's the IG. There's no running away. So I'm going to try as much as I can to give you important things that will always make you do it. Is that everything you read, you should convert it to a mathematical thing. Okay, I just read this to say she is twice as likely to draw. Okay, the probability. She's twice as likely to draw the game as to lose the game. So if she is twice to draw, that means there is 2 on drawing. Whatever you put on lose, put 2 times that on drawing, because she's twice as likely to draw. So that's what we did. We put an X on lose because we don't know it. We don't know it yet. But we know that draw is going to be 2 times that, because the statement says that. Now, the good thing about it is you didn't just read. You have written something in terms of maths. You have written something in terms of maths. So now what you're then going to come and do, you're going to say, what I know is that probabilities add to give me 1. Now you are beginning, ideas are beginning to come now. You have this probability, you want to find others, you already now know that they should add to give me 1. So you're going to say probability of win plus the probability of the loss. Okay, probability of win plus probability of loss plus the probability of a draw. All this should give us 1, because probabilities add to give you 1. Are you taking it from nowhere? No. We are taking this second part, that probabilities add to give us 1. So now we'll say, do you know the probability of winning? Yes. Don't rush, just do step by step. Probability of winning is 0.28. Plus, do you know the probability of the loss? Yes, it's x. Plus, do you know the probability of a draw? Yes, it's 2x. And these give us 1. Now you can find your x. You see? You'd now say x plus 2x. You now need to know how to add. This is a 1 in front of this x. Here there is a 2 in front of this x. So it'll be 3x. So you have 0.28 plus 3x is equal to 1, which means 3x will be equal to 1. Then you take 0.28 to the other side. Here it's adding. When it goes to the other side, it will subtract. Now you have it saying 3x is equal to 0.72, which means x will be equal to 0.72 over 2, which means x is equal to 0.36. Now they want probability that she what? She loses the game. Oh, okay. Probability of loss is equal to x, which means yes, help me. Yeah, divided by 3, well done. And it becomes what? 0.24? Okay, good. Well done. Probability of loss now will be x, which we now know what x is. It's 0.24, so the probability of your loss is 0.24. And you're done, okay? 0.2. Why did I divide by 3? We took this 3 to the other side. It will now divide, okay? Now you have taken it. So, listen, it may not be what you wanted. It may not be what you expected from maths. It may be a weird question to you, but try to learn things that will help you do your version. Because your version is coming, your own version. Remember, important things were, we wrote down things that they told us, and then we tried to apply the rules that we know. We tried, and we got the answer, okay? We tried to apply the rules that we know, and we ended up getting the answer. These are the only 3 rules. It's about practice. Practice makes perfect. Even if you redo the questions on your own and try, that's still fine. Look at this one now. Jacinda, or whatever her name is, plays the game 150 times. Find the expected number of times she wins. Now, I've told you many times that the only formula in probability to do with number of things is here. Now we are going to see, they want number of what? Number of wins. So that means we need what in here? This formula, it will be saying probability of wins is equal to number of wins over the total number of trials. So that's what you'll come do. You say probability of a win is equal to number of wins over the total number of trials. Okay? Probability of anything. They want number of wins. So you need to use this first formula here. It's the only one which has number of things. So obviously it's the one, but now you need to know how to use it. If they are talking about find the number of times she loses, then you'd say probability of loss in here. Find the number of times she draws, here you say probability of draw. So whatever you need here should be the same which that is in here. Probability of draw, number of times she draws over the total number of times. That's how it keeps going. Probability of win, number of wins over the total number of trials. Probability of loss, the number of losses over the total number of trials. This is that formula. It will help us to find number of things. As long as we are in the topic of probability and we want to do number of things, we use formula number 1. So you're going to need to be able to use it. So now they want the number of wins, expected number of times she's expected to win. So we take total number of trials to the other side. We're going to say the probability of a win times the total number of times or trials. This gives us the number of wins. This will give us the number of wins. What is the probability of a win? We found probability of a win. They told us 0.28. So 0.28
times the total number of trials, 150. What answer do you get as the number of wins?
What's 0.28 times 150?
42 wins. So 42 wins. So here you can put your 42 wins.
Well done. The best thing about how you are doing it is you have a procedure that you are following. That's the best thing about it.
And that's what makes me so happy. Look at this one now.
We're going to read the question. But before we read the question, we see the word probability.
So we're going to make it easy for us. We need to put the ways to get probability that we know. Okay, off here.
Okay. The moment we see the word probability, we put what we know about it. We trust our knowledge. Okay, guys?
We trust our knowledge. Probability of any event is equal to the number of successes over the total number of trials. That's the first one. For the second one, sum of probabilities is 1.
And this one, you use it also if they ever ask you, what is the probability of not something?
You will remember that sum of probabilities is 1. Remember this. Then the third one, if you see the word and, you should multiply. Okay? If you see it appearing anywhere, remember to multiply. When you see the word or appearing anywhere, remember to add. If you see the word both, find the probability that both something, then you're going to change it to and, then you multiply.
So this is enough. These are the 3. Let's get to work, okay? These are the 3 things we're going to do. These are the only 3
that we have. Let's do this question. Okay, I'm going to copy these 3 methods. We're going to be putting them every time we're about to answer the question. We're going to make sure we have these, okay? All right, now let's do find the probability. This is the question, okay? This is the question. Find the probability that she picks a red pen. Probability that she picks a red pen. We have been given the number of pens. Once you give me number of things, I know how to get probability. Probability of picking a red will be how many red are there? Okay? We are using this first one here.
This is the one we use. The number of successes, which means how many red
do you have? 5 red, okay? So it's going to be 5 red things over what is the total to get the probability of red? Is the number of red over the total. 5 plus 3, which is 5 over 8. This is how you get the probability of that she picks a red pen.
You're done. Well done. Now, let's get to this one. Here, I want you to know that this is the last type of question that you should be meeting, and things can change in this question. When you are now having somebody who is selecting or choosing more than one time, try to make sure you know whether they are replacing or not replacing. And I'll show you what will change as we keep doing questions. So don't force things into your head. But just remember that if I ever pick something and I replace, that means that the total number of things will never change. Okay? Are we together? Yes. If I ever pick and replace, that means don't change the total. But if you pick and you are not replacing, please remember to be changing the total. I'll show you when we get there. Let's see here. Complete the T diagram, and there's a word which caught my eye which says replaces it. So the fact that they are replacing, that means the probability I'm going to see here should be the same one that I see here, because we are replacing.
So what is the probability of red? We know probability of red already. Okay, we found it in here to be 5/8. So probability of red is 5/8. Now, to get this one, you put in your calculator 1 minus open bracket 5/8 close. You should get an answer, and your answer should be 3/8, which is automatically the one that comes here, because these two should add to give you 1. So automatically, since we are replacing, this 3/8 is the one coming here, and this 5/8 is the one coming on red. Since we are replacing, this 3/8 is coming here, and this 5/8 is coming here. Now we have a tree diagram. Simple. Because we were replacing. That's why nothing changed. Yes, Ms. Vita? Mm-mm. 1 minus open bracket 5/8. Be careful there. 1 minus, they add to give you 1. This one and this one add to give you a big 1. So when you want this one, you say 1 minus this one. So 1 minus open bracket 5/8 close bracket. You should get 3/8. Right? Good. Good. Then now it comes to, so here we hadn't started. Here we were filling our tree diagram so that we can now start. So here what we were doing was filling the tree diagram, because now we have probabilities. Tree diagram just helps you to know the probabilities so that you can now answer the questions. It's not the question itself. Find the probability that Maya picks 2 pens that have the same color. So both of them have the same color. That's what she wants. She wants you to find the probability that she picks 2 pens that have the same color. So the fact that she is picking 2 pens, that means we're going to be using the words and the word or. Okay, because we are doing something more than once. So now, how do we pick 2 pens that have the same color? What are the ways that we can pick 2 pens that have the same color? If we pick blue on the first pen, then what color would we pick on the second? Blue. Or if we pick red on the first one, then what would we pick on the second? Red. Then we would have met the condition. So to pick pens, 2 pens that have the same color, you're going to say probability of same color. How do we get the same? Now this is where you have to be creative. Make sure you don't get the same color. Either I'm going to say blue and blue. So this will be the probability of blue and blue. Or there's another way, which is going to be red and red. So this is how I get pens of the same color using the keywords, which is the third thing here, which is the third thing about probability. That's what we use here. So this is used when there is combination. These words, you're going to be using them when you are doing something more than once. So blue and blue. My screen? Ooh, you can't see my screen? It's okay? Well done. So now we know what blue and blue means. We know that the word and, you multiply, the word or, you add. When you use it, we should know how to use them. Then we must be able to now change them. Yes, Ms. Vita? You have a question? See, your hand is up. Okay. So this now becomes the probability of blue times the probability of blue, because you have the word and. So you can even do it one time. What's the probability of blue in the first one? 3/8. And you multiply. Probability of blue on the second one. 3/8 again. Put in brackets. Plus, because of the word or,
You open another bracket. Probability of red, what is it? It's 5 over 8. So it'll be 5 over 8. And times. Probability of red again, another 5 over 8. And this becomes equal to 3 by 3, 9, over 8 by 8, 64, plus 5 by 5, 25, over 8 by 8, 64. You see? Which becomes now 34 over 64. There we go. I don't have a number that can go into both. What number can go into both? 2 becomes 17 over 32. Okay. So this becomes 17 over 32. And you get the 3 marks. Don't let me down. Are we together? Next question. Oh, now there is no replacement. Now there is no replacement. So let's do a tree diagram so that we can see this picture. Let's do when there is no replacement now. Let's do a tree diagram so we can see this picture. She now picks 3 of the 8 pens. She picks 3 without replacement. Now they say find the probability that 2 are blue, 1 is red. We'll get there. So let me say this. If somebody is picking more than once or choosing more than once, you must be able to make a tree diagram. Don't let me down. You know that we have blue pens and we have red pens. So we can make a tree diagram like this. You start somewhere at the center, okay? You need space. So you're going to say in my tree diagram, this is going to be blue and this is going to be red. And obviously this is the first pick. Then you go again like this. This is going to be blue. This is going to be red. This is going to be blue. This is going to be red. And this is obviously the second. Then this is going to be blue. This is going to be red. This is going to be blue. This is going to be red. You continue from every single position. Ooh, they'll be so shocked. How is this student so good? Blue and red, and then here it is again blue, red, like that. This is how you can make a tree diagram. This is the third part. Now, when we started with red, what was the probability of red? 5 over 8 blue, 3 over 8. So, let's start here. 5 over 8, then blue, 3 over 8. Let's say you pick red. So that means you go this way. So that means you are now going to the next step. You have picked red. How many red remain? 4 over. The total is now 7. But how many blue remain? We went down this path for red. So blue are still 3, but they're now over 7. And let's say we go red again. This now becomes 3 over 6. Don't forget to reduce the total as well. Then blue is still 3, but the total is being reduced, so it's 3 over 6. Are we together? Now let's follow. We should follow our tree diagram. Let's say you choose red, then you choose blue. Then you choose blue again. If you choose blue, here it is 3 over 7. Right? So when it comes here to the next blue, it is going to be 2 over 6. You reduce by 1. Then the red, what they were here is what they'll be here. It's still 4, but it's over 6. Now, if you choose blue, then what will be the next time you need to choose blue? It'll be now 2 out of 7. If you go blue, then what will be red now on this next step? What will be? It will be, red was what here? 5. But it's no longer over 8, it's now over 7. So this is a bit of a, I mean, you can be able to do it. A bit of a tree diagram. You should be able to do it. It's not an easy one. And then you can keep going. Here we chose blue here. So that means in the next one, how many blue are left? 1 out of 6. In this the red here, it's 5 over 7, which means here it's still 5, but it's now over 6. Because total always goes down. Now, here we chose red, which was 5 over 7. So what red remains here is 4. Out of what now? 6. And then these 2 over 7 will be now 2 over 6. Now find the probability that she picks 2 blue pens and 1 red. Probability, so now we're writing. Probability of blue and blue and red. This is going to be equal to probability of blue is 3 over 8 times probability of blue again 2 over 7 times probability of red now, which is 5 over 6. Are we together? Or put all the scenarios. Here we want, they didn't say she picks a blue, then a red. No, she should just pick 2 blue and 1 red. Another scenario would be if she says blue, then red, then blue. So you can also say or probability of blue blue and red and blue again. This is the other way we can get 2 blues and 1 red. Or the last and final way to get 2 blues and 1 red is probability of red, and you now say blue, and you say blue again. So actually when I came to think about it, that's when I began to see that we must use keywords. They just want 2 blues and 1 red. Here are the possible ways. Come on, I know you can do it. Ways of getting 2 blues and 1 red. Either it will be blue, blue, red, or blue, red, blue, or red, blue, blue. Now for blue, blue, red, what is it going to be? Blue on the first, that's 3 over 8. Times blue here, 2 over 7. Times 1 over 6. Here. Okay? This should be a formal question. Okay, 3. Then you say or, which means you must add. Blue, red, and blue, what would it be? What is blue? 3 over 8 times red, 5 over 7 times blue, 2 over 6. Here this was supposed to be 5 over 6 plus red, blue, blue is now red here, which is 5 over 8, and blue, 3 over 7, and blue again, 2 over 6. I don't know. You can try this. What do you get? This 3 marks makes me question if they wanted you to do all the different ways to get 2 blues and 1 red. $15 over what? 53. Okay, I'll put a star on it. 56. But some of you are getting, it's about keywords. Okay? Let's do this one. Remember, first thing, put your 3 formulas, okay? Don't change the method. I'll put my 3 formulas here. Then find the probability that the bead is yellow. So I want to find probability of yellow. Do I have number of things? Do I have what? Let's get in and let's check. Right. A bag has 24 colored beads. Okay. Some are red, some are blue, and 10 are yellow. Okay, so probability of yellow will be the number of yellow, 10, over the total, 24. We've talked about it. The number for something over the total. And this will reduce to 5 over 12. That's going to be your solution. We use formula number 1. Number of things over the total number of things. Probability of yellow is how many yellow do we have? 10. Over the total, 24. Then we find probability that it is not yellow. So probability of not something, I said, probability of not yellow is going to be equal to 1 minus the probability of yellow. Which is 1 minus, what is the probability of yellow? 5 over 12. Can somebody punch and tell me what you get? You must get 7 over 12. Well done. 7 over 12 will be the solution. So, what are you learning? We use this one. Listen, the sum of probabilities is 1. If they ask you probability of not of something, probability that it will not rain, probability of not something, not something, not something. When you want probability of not something, it is 1 minus the probability of that something. That's how you get the probability of not something. Are we together? Another bag contains, here they've given us number of things. This will be a great exam. If Cambridge brings numbers of things, we are fine. Find the probability that the first marble is black and the second is white. So probability of black and white. White in the second. Okay, probability of black in the first and white in the second, and they are picking without replacement. So here is a tip. Once they say without replacement, try to do a small tree diagram. Okay, when you want to do a small tree diagram, here's what you do. You just take, what are the things that are there? You have white, you have black, and you have green. So it's like you say green, white, black. Then you say again on the second one. So this will be green, this will be white, this will be black. Then you go again, green, then white, then black. Then here, green, white, black. Then here, green, white. Okay. Now we can put probabilities. Okay, this is green, white, black. Green, white, black. Green, white, black. So in the first, what is green? Probability of green is 5 green over the total 5 plus 6 plus 4, which is 15. So it will be 5 over 15. Then for here, it's 6 over 15. Then 4, it is 4 over 15. Now, they want you to pick black on the first and white on the second. So you don't have to do the other. So you're going to do black on the first. Then what will happen on the second? If we go black, then on the second, this green was 5 here. Its number doesn't change, but the total is now 14. The white was not changed. The number is still 6, but it is now 14. For black, it would be, they said, for black, you have taken, it was 4 over 15. Now you remain with 3 over 14. So you're going to say probability of black on the first and white on the second is going to be probability of black 4 over 15 times probability of white in the second, which is 6 over 14. And this becomes 24 over. What is 15 times 14? What is it?
15 times 14? 200 and what? 200. 210, which we can now reduce to lowest terms. Wait, let me read. The marbles, find the probability that the first marble is black and the second is white. Yes, you just find probability that the first is black and the second is white. Here, what is it? Reduced to lowest terms. 14 divided by 210. 24 divided by 210. What over what? 4 over? 4 over 35. Okay. Well done. 4 over 35. You are doing very well. Now, find the probability that both marbles have different colors. Listen, let me teach you. If they say to you, find the probability that both marbles have different colors, we can do it. There are two ways to do it. If both are going to have different colors, tell me the different combinations we would put here. Remember, both, it means we are picking two. So I want to see you use the words or and the words and. What are the ways that we'll get different colors here? Either it would be blue and white, or blue and green, or white and something. Can you see? So you'll be saying this and this, or this and this, or this and. But there are so many situations like that to have different colors. If you go blue in the first one, you have to go white in the second. Or you can go blue and green in the second. Or you can go white in the first and blue in the second. Or you can go white and green. You can write all this and end up having something that you'll be, to say probability of blue and white. And white. Or it will be blue and green. Okay, blue on the first, green on the second. Or you keep doing that and now you change it to additions and multiplications. But that's too much. There is a shorter thing. You can get probability of the same color. Let's find probability that both have the same color. Then when we say 1 minus both having the same color, we will get probability of different. So let's start with both having the same. What is the probability that they both have the same color? It will be the probability of blue on the first and blue on the second. Okay, you can say probability of same color is equal to probability of blue on the first and blue on the second. We want same color. Or it is going to be probability of white on the first and white on the second. Or it is going to be the probability of green on the first and green on the second. Okay, and green on the second. That's great. Now you know what to do. You're the most experienced person right now. What is blue on the first? 4 over 15. And is a multiplication. Blue on the second will be now 3 over 14. Or you add. What is the probability of white on the first? 6 over 15. And you multiply. Probability of white on the second. So since we already chose white on the first, that means the next time we want to choose it, there are 5 left. Because white has already been taken. So we can continue here. Since this is 6 over 15, the next time you want to put white here, it will be there are 5 left, and the total is now 14. So it will be times 5 over 14. Or it will be green on the first, which is 5 over 15. and, which you multiply, green on the second. So since you've already taken green on the first, the second will be, this is 5 over 15. The second will now have 4 over the total will also now be 14. Why? Because we are picking without replacement. It's without replacement. So I want to see the total going down. Now you're going to say, what is this going to be? 4 times 3, 12 over 210. That's what you told me. To say 15 times 4 is 210. Plus 6 times 5, 30 over, you said 15 times this is 210. Plus 5 times 4, 20 over, you said here it is 210. Which now becomes, since all of them are over 210, you can just put a nice big 210. This will be 12 plus 30 plus 20, which becomes 62 over 210. Then you can try to see if you can reduce it to lowest terms. Okay? Try to see if you can reduce. What would you get? Yes, Simon. Yes. 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 Okay, that's still fine. If you don't want to reduce this one, it's actually okay. Just don't write it on here. Whatever you do with it, we don't mind. But what we should just want to see is now probability of different color. Since you already have of same, so it will be 1 minus the probability of same color. You now get probability of different colors. So this is going to be 1 minus probability of same is 62 over 210. What will you get? It is 70. It is what? Over 105. Okay. 74 divided by 105. You just punch like this. 1 minus, the calculator knows how to give you an answer. 1 minus, you open brackets, you say 62 divided by 210, you close. Okay, if you want to change it to a fraction, you press these buttons. Then you're going to have the thing. Okay, let's do this one. Find the probability. Look at the most important thing. I don't want to just run. I look at important words. There are important things in this that tell you what to do. Okay, you know that probability, we have 3 ways of doing this. First thing that you're going to see is that you've been given the number of things. Okay, you just keep reading. Second thing, you see the word replaces it. Okay, I'm not actually reading. I'm not reading. I promise you I'm not reading. And that's why I know I'm going to get it correct. I'm not fighting with the English. I'm looking for keywords. Okay, I understand the chapter. That's what you guys do. Then they want probability that ball is white. So you just write probability of white. Then now you can go back to the information. Don't try to understand the information. You are putting things in your head when your head wants to think. So just underline, okay, to say I will need you, I'll need you. Then you go to replaces it, which means probability does not change, total does not change. Then find the probability that the ball is white. How many whites do we have? 5. Over what are the total? 5 plus 3, which is going to be 5 over 8. So this probability is 5 over 8. Ding! Find the number of times she's to get white. Number of times, we've done it so many times. We know that once they say number of times, we use that formula, that one formula. They'll find number of times for what? To get white, so we need probability of white, because you want number of times that you get white, so we need probability of white. It will be the number of whites over the total number of things. So we'll take total number to the other side. You'd have probability of whites multiplied by the total number of things. This will give you the number of whites. You now see, what is the probability of white? You have it, 5 over 8. Times what's the total? They'll always give you the total. 120. So 5 over 8 times 120. This gives the number of y. This is going to be what? You can now punch in the calculator. You say 5 times 120, then you say divided by 8. $75. So 75 is equal to the number of whites. You just write 75.
We say to you, well done.
Last thing, okay? The rest will do. Oscar picks a ball from the bag at random. He then replaces.
Okay, thank you for that. So nothing will change. Nothing will change.
He then picks a second ball. Find the probability that the balls are the same color.
This one you don't even need a tree diagram because nothing is changing. You are picking twice, but nothing is changing.
So find the probability of same color. You say probability of same color will be equal to, what are the colors we have? White and we have black. And remember, we are picking 2 times. So it's either probability of white and, okay, same color. Probability of white and white, or the probability of black and black. Which is going to be, what's the probability of white? We got it. It is 5 over 8. Times, what's the probability of white the second time? It's still 5 over 8.
Because we are replacing.
Or you add probability of black. If white is 5 over 8, black is 3 over 8, because they should be 8 over 8 together. And you say times, black in the second is also 3 over 8, which is going to be 25 over 64 plus 9 over 64.
The top multiplies, the bottom multiplies.
And what will you end up having? Over 64, you have 25 plus 9. And you end up having 34 over 64.
Great. Find the probabilities that they are not
The same color. Probability of not same color. In other words, probability of different color. They could have said find probability of different color. It's the same as not of the same color. It's 1 minus the probability of same color, which is going to be equal to 1 minus 34 over 64. And you get 30 over 64, which you can reduce to its lowest terms. What is it? 15. Okay. 15 over 32.
So this is what I want to see.
I want to see this. This is prolific. You would have done exceptional stuff. Are we together?
Are we together, everybody?
Okay. Let me stop this maths part.
Those who don't have the solutions, please